Hello, my name is Stefan Kine. In this video, we will introduce Unigraf's 8K capable UCD-424 pattern generator and analyzer, and I'll describe how to use the features of UCD-424 using UCD Console user interface. UCD-424 is a USB Type-C DisplayPort alternate mode video generator and analyzer. It supports video resolutions up to 8K. It can be used for testing DisplayPort alternate mode receivers and transmitters, and USB power delivery function. UCD-424 supports both non-compressed video and display stream compression (DSC). UCD-424 also supports USB power delivery specification 3.0. UCD-424 is an authorized tool for DisplayPort and HDCP compliance tests. UCD-424 is authorized by VESA for performing link layer compliance tests on DisplayPort alternate mode sync and source devices. UCD-424 is authorized by DCP LLC for performing HDCP compliance tests on DisplayPort alternate mode receivers, transmitters, and repeater devices. UCD Console is a graphical user interface for all Unigraf's UCD family test equipment. With UCD Console, the user can use the pattern generator function to source video and audio, and use the capture function to monitor and store video and audio. With UCD Console, the user can monitor the status of the USB-C interface and DisplayPort alt mode. All UCD-424 parameters related to the USB-C interface or DisplayPort alt mode are available for the user through UCD Console dialogues. UCD Console also includes the dialog for running link layer and HDCP compliance tests. The test functionalities will be enabled with a separate license. UCD Console dialogs are organized by operating roles of the connected test equipment. The roles can be selected from the vertical tabs and the functions of the role from horizontal tabs. In this presentation, we will introduce UCD-424 roles: pattern generator role for testing sync devices like monitors, an analyzer role for testing source devices like mobile phones, tablets, or laptop PCs. Let us first concentrate on UCD-424's analyzer role and start from the first functional tab, USB-C monitoring, and its first subtab, Roles and Modes. Roles and Modes tab is divided into two parts. The left side is the status panel, while the right side includes configuration dialogs. Status panel on the left lists the various roles and statuses of UCD-424 after the connection negotiations with the tested USB-C device. The statuses are listed in groups. The uppermost group indicates the general statuses like power and data role and DP alt mode configuration selected. Fixed supply PDO lists the PD status settings for the connection party acting as source port. Contract RDO lists the PD status settings for the connection party acting as sync port. The lowermost group lists the actual measured values of the VBus, CC1, CC2, and VCON signal lines. The first control and configuration panel on the right is initial port role. It defines the role which UCD-340 presents itself in the start of the PD negotiation. Based on the needs of the two parties, this role might change during negotiations. The next two configurations are setting the DP alt mode preferences. When auto enter on connect is selected, UCD-424 P alt mode discovery after connection is made and enters DP alternate mode if suitable configuration is found. In manual control, the user can either prefer 4-lane operation when all 4 high-speed lanes are used for DP alt mode, or 2-lane mode where both DP alt mode and high-speed data are using 2 lanes. Clicking either 4 lanes or 2 lanes causes UCD-424 to restart DP alt mode discovery and advertise the corresponding pin assignment C and E or D. Alt mode capability allows the user to define which pin assignments C, D, and E UCD-424 supports. Please refer to user manual for detailed descriptions. Next, configuration panel is the swap buttons. The swap buttons allows the user to request a swap of either data role, power role, or the CC line where VCON is applied. When the Prevent DUT Swap Requests checkboxes are selected, the corresponding swap messages from DUT are ignored. The PDO section allows the user to indicate apply power data objects UCD-424 supports. Plus 5 volts, 3 amperes is always supported. In bottom panel, the control light indicates presence of the USB-C connection. Plugged, not plugged. The status text indicates the type of cable and the cable orientation. Pressing the reconnect button restarts USB-C connection negotiations. The other sub-tab in USB-C monitoring is Cable Info. This tab displays the information received from an active cable as a response to Discover Identity command. Let us move on to the Video tab, which is the preview dialog for captured video content. Preview is enabled or disabled from the button on the right. Resolution of the captured video, color mode, and color depth are listed in the bottom row. If color mode is other than RGB, with preview color mode, user can select if content is converted to RGB for preview or if original format is used. With these buttons, user can snap individual frames or store video sequences. Please note that if the captured stream is HDCP encoded, storing video sequences or frames is not possible. In Audio tab, the user can preview received audio signal and playback audio in the PC. The upper part shows waveforms of the received audio channels and the lower part the frequency spectrum of each channel. Up to 8 channels can be received. Preview can be enabled and disabled from the button on the right. With non-compressed audio formats, audio can be monitored in the PC. Select Playback Device here. The bottom panel indicates the received audio format. Sequences of the captured audio can also be recorded. Start recording with the Record button. Analyzer Role Link tab contains dialogues for monitoring and controlling data links in DisplayPort alt mode. Cable light indicates that the hardware has detected an upstream cable. HPD light indicates that the hot plug detect signal is asserted in logical high state. With HPD control buttons, the user can control the status of the signal and give long or short pulses. Link status displays the status of the link training and the link parameters negotiated between UCD-424 sync and the upstream source. The data is retrieved from the DPCD registers of the UCD-424 sync. The status is updated automatically. Link configuration allows the user to change the way the sync capabilities are announced in the DPCD registers of the UCD-424 sync. Other capabilities section includes controls of features like MST, FEC, and DSC. To update the new status to the DPCD registers, click Apply. Stream Status panel displays video timing details retrieved from the mainstream attributes, otherwise known as MSA, of the monitored stream. Frame rate is measured by UCD-424 local sync. Frame CRC displays the 16-bit values calculated with cyclic redundancy check function from the 3 color components of all pixels in the received video frame. In EDID tab, the user can access the data stored in EDID of the UCD-424 sync that is presented to the upstream source device. The user can read and program the contents of the EDID memory of up to 4 virtual MST ports. In the panel on the left side of the dialog, the user can view and edit EDID data in hex mode. EDID data can be read from a file or stored to a file for later use. EDID content can be edited in a separate EDID editor. In left panel of the EDID editor, the data is viewed in logical tree view. The content can be examined either on high level or in detail. The right panel shows the details of the currently selected item. Data can be retrieved or saved to a file here. In DPCD Tab, user can evaluate and change content of UCD-424 DP Sync DisplayPort configuration data registers. There are differences between DPCD versions. The user can select here the version for interpretation. There are two DPCD address range dialogs. Start address of the range can be set here. DPCD content can be edited in the hex mode dialogs. Parse details of the selected DPCD location is shown in the panel on the right. Register content can be saved in a file. HDCP Tab includes controls and the statuses for HDCP, which is High Bandwidth Digital Content Protection function. Since source device controls HDCP function, in Analyzer role, the user can only monitor the status and set the capabilities of UCD-424. HDCP Tab includes separate panels for HDCP version 1.3 and HDCP version 2.3. It will depend on the source device to select the version used. The status panel shows the status of HDCP handshake and sync. In configuration panel, the user can enable or disable HDCP capability declaration of UCD-424 sync device. SDP Tab shows the secondary data packets received from the source device. Received packets are shown in hexadecimal format. Please refer to UCD-424 user manual for a list of packets detected. Click Update to reread the packets. FEC tab contains control of the forward error correction feature, and FEC status log. Enabling the FEC feature is controlled by the connected source device. When source and sync devices are connected, source verifies if sync is FEC capable. This register in UCD-424 sync can be controlled by the FEC capable checkbox. Since a source device normally pulls sync registers after a new connection, selecting Generate HPD on change will issue a hot plug detect pulse and a new connection after FEC capability status is changed. FEC enabled light will indicate that source has enabled FEC function. Error counter panel will list the types of errors found in main lane symbols. The changes in the FEC status are listed in status log on the right. DUT testing tab enables running tests that are included in UCD-424 firmware. Please note that some tests are enabled by default with UCD-424 delivery, and some tests are enabled only by applying a specific license key in UCD-424 license manager. Please refer to the UCD-424 user manual for the list of available tests and licenses. The test categories available for UCD-424 unit are presented as separate tabs. Each test category contains individual tests to be run by clicking on the list. The results panel in the right shows which tests have been run and the results status, passed, failed, or skipped. Once the needed tests are selected from the list, the user can select how many times the tests are run, the delay between tests, and if the test sequence is stopped in case a failure is found. Users can follow execution of the test in the test log. Each step is described in detail. Test logs can also be stored as a report in a HTML file for sharing and evaluation with any web browser. Full test execution details with custom remarks will be stored in the report. Before running tests, the user must set parameters related to the test. The result of the test might be misleading if the DUT capabilities and the test parameters do not match. This is especially important when running compliance tests. Click Configure to open up a pop-up dialog related to the selected test category. As an example, let us have a look at DUT capabilities dialogs for DisplayPort link compliance tests. The capabilities dialogs are spread on 3 tabs, and each tab has several parameter groups. It is very important to set all parameters very carefully, since the compliance tests and pass-fail criteria is based on the selections made in these dialogs. The capability selections are described in detail in Chapter 3 of VESA DisplayPort version 1.4a Link Layer Compliance Test Specification. Click here to save the presets into a file. Now we have gone through all tabs in Analyzer role of UCD-424. Let us change to Pattern Generator role. The first tab is the same as in Analyzer role, USB-C Monitoring. There are again 2 sub-tabs, Roles and Modes tab, and Cable Info tab. The only difference in Roles and Modes sub-tab is in DisplayPort alternate mode controls. The available options are now reflecting the case when UCD-424 is a DisplayPort alternate mode source, in USB-C terms DFPD, to the one that we have already seen. UCD-424 includes a set of predefined common video timings and video patterns. A list of timings and patterns can be found in UCD-424 user manual. In Timing and Pattern dialog, user can select the time list, set video color mode, and color bit depth. Patterns can be selected from the list of predefined patterns, where the user can load a custom bitmap by clicking the image on the right. The predefined timings can be edited in the Custom Timing dialog, or defined in a pop-up Manage Timings tool dialog. After selecting proper values for the video signal, validate them by clicking Apply. In the Audio Generator tab, the user can set audio waveform, audio signal frequency, define the sample rate, and bit depth used, and the number of audio channels. Custom audio files can be used also as a source. Start and stop sending audio here. Link tab shows the status and control items for the DisplayPort link. HPD light on the top of the tab indicates the status of the hot plug detect signal. Link status panel shows the result of the link training with the connected downstream sync, selected link parameters, and the status of other connection features. The user can override here output level and pre-emphasis values selected during link training. Click Apply Overrides to validate changes. Please note that connected sync and source actively maintain the link. If the override settings result in link failure, the link will be automatically retrained and proper values set. In link configuration, users can set target capabilities for the link training. Click Link Training to apply. In link pattern, the user can select special patterns to be sent over a link. Please note that these patterns are not video and audio. They are special bit combinations used for development purposes. When selecting active video, normal audio and video are being transmitted over the link. Frame CRC displays the 16-bit values calculated with cyclic redundancy check function from the 3 color components of all pixels in the sent video frame. EDID frame. EDID and DPCD tabs are in Pattern Generator role, similar than in Analyzer role. Please note that the information is read from the connected sink, not UCD-424 source itself. In HDCP tab, the state and analyzer side. The difference is in the control panel. Since the transmitter is controlling HDCP function, the checkboxes for enabling HDCP are here. Transmitter can naturally enable HDCP only if receiver declares that it is HDCP capable. In FEC tab, users can control forward error correction feature. Clicking Enable and Disable FEC buttons will start and stop the function provided that the connected sync device is FEC capable. If Prefer FEC Enable is selected and the connected sync supports FEC, UCD-424 will start FEC Enable sequence after a successful connection. In Error Generator, generator errors of type selection will set how many errors will be inserted into one FEC block and sync symbol. Sync error counters indicate that the number of errors that the connected sync device has detected. The values are read from sync DPCD. The two debug buttons enable sending either FEC enable or FEC disable sequence in main link. Status log shows FEC status changes. The functions in Sync DUT Testing tab are similar to Source DUT Testing and Analyzer role. The available tests in tabs depend on the licenses present. Event log is a common generator and analyzer roles of UCD-424. Capturing transactions is started here. Based on UCD-424 role, the user needs to define the items to be logged either from DP alternate mode input or output. There are three transaction list tabs. The user can evaluate all logged transactions in Event Log tab, and alternatively, only aux channels in the two aux analyzer tabs. Logged items selection is common for all three. Parsed details of the items selected in transaction list is shown in the dialog on the right. The logged transactions can be saved either as a binary data or as HTML reports that can be shared and evaluated with any web browser. Thank you for watching this video on the UCD-424. For more information, www.unigraf.fi.